Let's talk about numbers. For today's lesson, we will discuss domain and range of functions. We have here the learning competencies. The learner is able to determine the domain and range of functions. First, we will define the following. What is domain? Domain of a function is a set of all possible values that the variable x can take or the set of inputs. And range of functions is the set of all possible values that the variable y can take or the set of outputs. Next, we have here the definition of a polynomial function. Polynomial function p of the degree n is a function that can be written in the form of this one. Again, a polynomial function of the degree n is a function that can be written in the form of this one, where a sub 0 is an element, where a sub 0 to a sub n is an element of real number, and a sub n is not equal to 0, and a sub n is a positive integer. Each sum-non is a term of a polynomial function. The constant a sub 0 to a sub n are the coefficients, and the leading coefficients is a sub n, and the leading term is a sub n x to the n, and the constant term is a sub 0. In layman's term, if we talk about polynomial function, it is an expression the wherein the exponent of the given function is positive integer. Next, we have a rational expression. A rational expression is an expression that can be written as a ratio of two polynomials. Next, we have the interval and the set notation. You need to recall this interval, set notation, and the representation of the given interval. So we have here this one. It is called an open interval AB. If we talk about open interval AB, it is from A to B, all number from A to B, but A and B are not included. It is bounded from A to B, but A and B are not included. The next, we have an interval AB or a closed interval AB. Here, it is from A to B, or all number from A to B, and A and B are included. That's why it is called closed interval. The next, we have half open interval AB. Here, the notation here is it is an open interval it is closed interval in A but open interval in B. So therefore, it is from A, including A, to B, but letter B is not included. The next, we have half open interval AB, but in this case, A is an open interval, but B is a closed interval. So therefore, A is not included, but B is included. All numbers from A to B except A. The next is we have open interval A to positive infinity. We talk about open interval A to positive infinity. All number from A to positive infinity, but excluding A. So it is only bounded by A from A to positive infinity, but excluding A. The next, we have closed interval A to positive infinity. So here, A is included to positive infinity. So again, if we talk about open interval, it is a number from that interval, but that interval or that particular number is not included. So for example, we have if A is 1 and B is 2, if we talk about open interval A2, all number from A to 2, but but 1 and 2 are not included. Then last one we have here the set of real numbers. The set of real numbers can be written as negative infinity. So again, this is negative infinity to positive infinity. Infinity. This is the set of all real numbers. So therefore, in an interval, in a graph or in a real number line, it is from negative infinity to positive infinity. So next, we have here the steps on finding the domain of functions. Solve First, we have solve the equation for y in terms of x. So if y is a polynomial, then the domain is the set of all real numbers. The number 2, if y is a rational expression and contains an expression d of x in the denominator, the domain is the set of real numbers except those values of x that make the denominator, which is d of x, equal to 0. And number 3, if y contains a radical expression n root of r of x, where n is an even natural number. If we talk about even natural number, it is divisible by 2. The domain is the set of all real numbers except those values of x that make r of x less than 0. So we have here an example to fully understand how to find the domain of function. So we have number 1, f of x is equals to x squared minus 4. So solution again, first, we have f of x is equals to x squared minus 4. Change f of x to y. So again, change f of x to y. So we will write y is equals to x squared minus 4. So we just change f of x to y, then copy the original expression. Next, we have here, therefore, the domain will be the set of all real numbers, which is negative infinity to positive infinity. So again, this is the set of all real numbers, which is from negative infinity to positive infinity. Why? It is because the given expression, which is x squared minus 4, is a polynomial. In the first condition given, if it is a polynomial, the given domain will be negative infinity to positive infinity, or it is the set of all real numbers. So if you already know that your given function is a polynomial, then the domain is negative infinity to positive infinity. So in a real number line, we have this one. So in a real number line, we have this one. So that is from negative infinity to positive infinity. And next we have number 2. f of x is equals to x squared plus 3x plus 1. So solution, so again, f of x is equals to x squared plus 3x plus 1. Change f of x to y. So we have here, from f of x, we write this one as y, then copy the entire expression. The question is this a polynomial? Is x squared plus 3x plus 1 a polynomial? Yes, that is a polynomial. So therefore, the domain is from negative infinity to positive infinity, or the set of real numbers. So in a real number line, so we have this one, from negative infinity to positive infinity. So again, we know that This is a polynomial, so therefore, the domain is from negative infinity to positive infinity. So next, we have f of x is equals to x plus 1 all over x minus 1. Solutions. So again, copy the given f of x is equals to x plus 1 all over x minus 1. Change f of x to y. So again, the original equation or the original function f of x, we will change that to y. So we have y is equals to x plus 1 all over x minus 1. So that will be the domain of y is equals to x plus 1 all over x minus 1 is the set of real numbers except those values that make the denominator 0. This means that the denominator x minus 1 cannot be equal to 0. So here, what number if we substitute to the denominator, which is this one, that will give us 0? So obviously, if x is equals to 1, 1 minus 1, that is 0. So therefore, the domain will be from negative infinity to 1, approaching 1, but not including 1, union 1 to positive infinity. So again, it is the set of all real number except 1, since the moment x is equals to 1, the given function is undefined. So therefore, in a set builder notation, the domain will be negative infinity to positive 1, but not included 1, union 1 to positive infinity. So in a real number line, we have this one. So that is from negative infinity going to 1, but not included 1, then from 1 to positive infinity. Next, we have f of x is equals to x squared plus 1 all over x minus 2. Solutions. So again, copy the given. The next, change f of x to y. So we have, so again, we have f of x, then we'll write f of x as y equals to x squared plus 1 all over x minus 2. So now, the domain of y is equals to x squared plus 1 all over x minus 2 is the set of real numbers except those values that make the denominator 0. This means that the denominator x minus 1 cannot be equal to 0. So therefore, the domain will be, so what number if we substitute to the given x, this one, that will yield 0? So obviously that is 2. Since 2 minus 2 is equals to 0. So therefore, the domain will be the set of all real numbers except positive 2. So in a set builder notation, we write that as negative infinity to positive 2, but again, excluding 2. So we use this notation, union 2 to positive infinity. So in a real number line, so we have this one. So from negative infinity to 2, but not included 2, then union 2 to positive infinity. So next we have number 5. Find f of x is equals to x squared plus 1 all over x plus 2. I mean, find the domain of the given functions. So we have, so still copy the given, then change f of x to y. So we have y is equals to x squared plus 1 all over x plus 2. So the domain of the given function is the set of all real numbers except those values that make the denominator 0. This means that the denominator x plus 2 cannot be equal to 0. So therefore, the domain will be, so again, what number, if we substitute to the denominator x plus 2, will yield 0? So if x is equals to negative 2 plus 2 is equals to 0. So therefore, the domain is all real numbers except negative 2. In a set builder notation, we write from negative infinity to negative 2 but not including 2. So we use this notation, union negative 2 to positive infinity. So in a set builder notation, in a real number line, we have this one from negative infinity to 2 but not include to negative 2 but not included negative 2, then negative 2 to positive infinity. So next we have number 6. F of x is equals to square root of x minus 2. So in this case, it is in the form of radical. So the solution will be same with number 1 to number 5. Just copy the original given, then change f of x to y. So y is equals to the square root of x minus 2. So here we have the domain of y is equals to the square root. The domain of y is equals to square root of x minus 2 is the set of all real numbers except those values that make the radicand, which is x minus 2 less than 0. So again, all real numbers except those numbers that will make the radicand x minus 2 less than 0. So therefore, the domain will be from positive 2 to positive infinity. Why? Because the moment x is equals to 2, the moment x is equals to 1.9 or 1.999 minus 2, so that will be negative. So 1.9 minus 2, that is negative 0.1. So obviously, all numbers from 1.99999 to the negative infinity will be excluded since the result of the radicand will yield negative numbers or less than 0. So therefore, the domain will be from 2, which is including 2, so bounded by 2. So we use this notation, close interval, to positive infinity. So in a real number line, we have this one. So that is from 2 to positive infinity. So we will exclude all values from negative infinity to 1.999, or any number that is approaching positive 2, less than positive 2, since that will give us a negative answer. So next we have number 7. F of x is equals to the square root of x plus 2. So the solution will be f of x is equals to the square root of x plus 2. Change f of x to y. Then y is equals to the square root of x plus 2. So we have the domain of y is equals to the square root of x plus 2 is the set of all real numbers except those values that make the radicand x plus 2 less than 0. So here, what number that will give us negative answer? So obviously that will be negative 2.01 or 2.001 will give us negative answer, negative radicand. So therefore, we will exclude all number from negative 2 to positive infinity will be the domain. And we will exclude all numbers from negative infinity approaching negative 2. Since the moment this will be 2.2.001, negative 2.01 minus 2, the answer will be equal to negative. So we will exclude all numbers from negative infinity to negative 2, approaching negative 2. So therefore, the domain will be from negative 2 to uh, positive infinity, including 2. So it is bounded by negative 2 to positive in infinity. And all numbers from negative infinity to 2 will be excluded. Next, we have here the summary. So summary for number 1. So we have number 1 to number 7. So we have for number 1, the domain is negative infinity to positive infinity. Number 2, we have negative infinity to positive infinity, or the set of all real numbers. Why? It is because the given expression or the given function is a polynomial. The next, for 3, 4, and 5, we have here, for number 3, it is from negative infinity to 1, union 1 to positive infinity. Since the moment if x is equals to 1, then the given expression will be undefined. So for number 4, it is from negative infinity to 2, union 2 to positive infinity. Since the moment x is equals to 2, the given expression will be undefined. The number 5, negative infinity to negative 2, union negative t to positive infinity. So therefore, we will exclude again here negative 2, since it will give us 0 denominator, and that is undefined. So here from number 3 to number 5, if you observe, we have a pattern. If it is a rational function, your answer will be most likely in this form. But the question here, what will be the excluded numbers? But again, the pattern will be from negative infinity to a certain number, union that certain number to positive infinity. The next, we have number 6. F of x is equals to the square root of x minus 2. So the domain is from close interval 2 to positive infinity. Then for number 7, we have close interval negative 2 to positive infinity. Here, if you observe, if it is in a radical, the domain will be most likely in this form, but the question will be, what will be the excluding number in order for the radicand will not be equal to negative. So next, we have how to find the range of function. So we have write f of x as y. So in a domain, we need to write f of x as y. Then in finding the domain, we need to write f of x as y. Then we need already to categorize if it is a polynomial function, if it is if it's a rational function, if it is a radical function. Here, after you write f of x as y, you need to solve the equation for x in terms of y. Then we have the condition. If x is a polynomial, the range is the set of real numbers excluding or exclude all restriction in the defining equation where y is in terms of x, if there is any. The next, number 2, if x is a rational expression and contains an expression dy in a denominator, the range is the set of real numbers except those values of y that make dy equal to 0. And lastly, if x contains a radical expression, the n root of r of y, where n is an even natural number. If we talk about even natural number, that is divisible by 2. Positive number that is divisible by 2. The range is the set of real numbers except those values of y that make r of y less than 0. So we have here an example. Find find the range of function f of x is equals to x squared minus 4, and the given domain here obviously is negative infinity to positive infinity since it is a polynomial. So next we have the solutions. Write f of x as y. So we change f of x to y, then copy the original equation. This will imply that y plus 4 is equals to x squared y. By transposition, so isolate y. So we have here x squared minus 4. So transposition or the additive inverse. So from negative 4, we will have positive 4. So that is y plus 4 is equals to x squared. So next, eliminate the square. So we need to take the square root of the entire expression. So we have here the square root of x squared is just x. Okay, so again, we take the square root of the entire expression in order to eliminate the x squared or the 2 exponent of x or the x squared. So we have the square root of y plus 4 is equals to x. So therefore, the range of x is equals to the square root of y plus 4 is the set of real numbers except those values that make the radicand x plus 4 less than 0. Therefore, the range r, or denoted by letter r, is from negative 4 to positive infinity. Why? Because the moment y is equals to 4.01, the given negative 4.01, if it is negative 4.01, then minus negative 4.01 plus 4, that is negative. So therefore, we will exclude all numbers from all numbers below negative 4. From negative infinity approaching 4, we will exclude all numbers. So therefore, the range will be negative 4 to positive infinity. So in a real number line, we have this one. So from negative 4 to positive infinity. And all numbers from negative infinity approaching negative 4 will be excluded. So next we have number 2. F of x is equals to the square root of x minus 2. And the domain here is from 2 to positive infinity. So again, write f of x as y. So y is equals to the square root of x minus 2. And y, then we have, in order to eliminate the radical sign, so we need to square the entire expression. So this is, we square the entire expression, therefore this will be y squared is equals to x minus 2 since the square root sign and that square is cancelled. So therefore, by transposition from negative 2, we have y from this side, which is negative 2, by transposition, we have y squared plus 2 is equals to x. So therefore, the range of the range of x is equals to y squared plus 2 is the set of all real numbers. This one is an polynomial. So therefore, the range is the set of all real numbers. Since the domain, which is the given domain that is from positive 2 to negative infinity, so we take the intersection of that. So from negative in from negative infinity to positive infinity, the range intersecting to the domain that is from 2 to positive infinity, the range will be from 2 to positive infinity. So therefore, the given range will be from positive 2 to positive infinity. And in real number line, we have this one. So from 2 to positive infinity, excluding all numbers from negative infinity to 2. So for your exercise, try to do the following. So we have f of x is equals to x squared minus 3. You need to find the domain and the range of function. Number 2, f of x is equals to the square root of x plus 6. Number 3 is f of x is equals to 1 over x minus 4. Number 4, f of x is equals to x all over x plus 3. And number 5, f of x is equals to the square root of 3 minus x. So again, thank you very much for your time.